The UPSC has asked many questions on power grids in various question papers. Let's find out what is a power grid. A power grid, also known as electrical grids or electricity grids, are complex networks of interconnected components that work together to generate, transmit and distribute electrical energy. These grids form the backbone of the electric power infrastructure and plays a very crucial role in delivering electricity from power source to end users. The power grid starts with the generation of electricity from various sources. Common power generation methods includes fossil fuel techniques, which use power plants that burn coal, natural gas or oil. We also have renewable energy, where power generated from renewable sources such as solar, wind, hydroelectric and geothermal energy are concerned. Next is the nuclear energy, where electricity generated through nuclear reactions are noted. Once electricity is generated, it needs to be transmitted over long distances from power plants to population centers and industrial areas. High voltage transmission lines and associated infrastructure such as substations are used for this purpose. The substations are key components in power grids where voltage levels are transformed. They play a crucial role in stepping up or stepping down the voltage for efficient transmission and distribution. The distribution networks take electricity from the transmission system and deliver it to end users. This includes residential, commercial and industrial customers. Distribution systems typically operate at lower voltage levels and compared to the transmission system. The power grids are monitored and controlled from central control centers. These centers use advanced technology to manage the flow of electricity, monitor equipment health and respond to disruptions or emergencies. Maintaining grid stability and reliability is very critical. Power grids must balance the supply and demand of electricity in real time. Control systems and technology help regulate voltage and frequency to ensure a stable power supply. Modern power grids are evolving into smart grids, integrating advanced communication and controlling technology. Smart grids enable better monitoring, control, and optimization of the entire electricity system, improving efficiency and reliability. Some regions have multiple power grids that are interconnected to enhance reliability and resource sharing. Interconnections allow for the transfer of electricity between different geographical areas. Power grids must be resilient to various challenges, including natural disasters, equipment failures, and cyber threats. Planning and investments in grid infrastructure contribute to great resilience. In some cases, neighboring countries may connect their power grids to facilitate cross-border electricity trade and improve resource utilization. Microgrids are smaller scale, localized grids that can operate independently or connect to the main grid. They are often used for specific communities, campuses or industrial complex and can incorporate renewable energy sources too. The energy storage technologies such as batteries are increasingly integrated into the power grid to store excess energy during periods of low demand and release it during peak demand, contributing to grid stability. The power grids are essentially for meeting the increasing demand for electricity in a reliable, efficient and sustainable manner. They form a critical infrastructure that underpins modern societies and economy. The demand response programs involve adjusting electricity usages in response to signals from the grid operator. The energy storage systems such as large-scale batteries are becoming integral to the power grid operations. Again, the super grids are ambitious projects that aim to create large-scale continent-spanning electricity transmission networks. These networks could have facilitated efficient sharing of renewable energy sources across regions and countries. Some countries and regions are exploring the concept of energy islands, where a significant portion of energy need is met through renewable sources. This may involve a combination of local power generation, energy storage, and grid interconnection.